Let's have a little look at pressure. Now I've got here is just an ordinary tin can, nothing much going on, nothing much happening to it. But actually in science, a lot is going on in this tin can. Constantly, all the time, this can has been bombarded with particles from the air, hitting it at great speed from every direction. Now this exerts a great pressure on the outside of the can, pushing it inwards. But, as you can see, the can has been crushed inwards. That's because, inside the can, there's the same type of air, pushing outwards with the same pressure, and the pressures are balancing. We call this atmospheric pressure, pressure from the atmosphere. So I pick this can up and dunk it into some water. The same thing's happening. This time, pressure from the air, atmospheric pressure, is pushing out from inside the can, and pressure from the water particles are hitting it in from outside the can, balancing the pressure, and the can stays as it is. What we're going to do now is we're going to have a little look, fill it up a little bit, so we can see what happens if you remove the pressure inside. We're going to turn this Bunsen onto a roaring flame and heat up the can and the water inside. So we know in the bottom of the can there's a little bit of water, and when that gets hot enough, it will start to boil, turning the water to steam, or water vapour. As that steam and water vapour builds up inside the can, it will push the air out, and you should be able to see a stream of water vapour coming out of the can. Just leave it another 5-10 seconds, you should be able to see something. There we go. A nice steady stream of steam is coming out of the can and filling the entire can with water vapour as opposed to just the normal air we had before. What we're going to do now is we're going to take this steaming can from the Bunsen and place it in the trough of water. And that trough of water is going to exert the same pressure on the outside pushing in, but inside the water vapour will very quickly all turn back into water as it's cooled by the water outside of the trough, and there'll be a vacuum inside. The vacuum means there's nothing pushing from the inside outward. We'll see what happens, shall we? We'll take the can. The can is instantaneously crushed. Very small. Far smaller than I can get it if I was to crush it with my hands. Let's have another quick look. Heating the can, water turning to water vapour, pressure inside and pressure outside are balanced, and the water vapour hitting outwards from inside and the air pressure hitting inwards from outside. Nice steady stream of steam coming out. Transfer the can from the Bunsen into the water. Bang! Suddenly, the pressure from inside is removed, and you can really get an idea of just how strong the pressure on the outside is.